Welcome to Unit 1, Lesson 6, Representing Sequences. Our learning goal, let's look at different ways to represent a sequence. Okay, so whenever we have an activity, the first thing we have to do is make sure that we read the directions carefully. For each sequence shown, find either the growth factor. Growth factor only goes with geometric sequences, and we know what a geometric, we multiply or divide. Rate of change goes with arithmetic sequences, and for arithmetic sequences, we add and subtract. So now, all we got to do is find the growth factor. So for the first one, 5, 15, 25. So we're adding 10, which makes this an arithmetic sequence. The next one, 5 less than means minus 5 halves. We've seen this wording several times. Less than means the negative goes in front of the 5 halves. And this is arithmetic. Now the next one is curved down. It could be a geometric, but let's check the outputs. Remember, a sequence is the outputs. So let's check what we are given here. So we got 16, we got 8, 16, 8, 4, 2, 1. It looks like it's dividing by 2 or multiplying by 1/2, and that would make that geometric. Okay, 4 times -2. This looks geometric, but it's not. It's neither. And I'm going to show you why. If our first term is -5, when we multiply by -2, we get +10, then -20, then +40, then -80. This will not make a curve. When you're multiplying by negative, the numbers keep switching back and forth. So you will not get a curved graph like you see in 3. The next one, what we have is 0.1 is the change, but I also need an operator. An operator, add, subtract, multiply, or divide. And that makes this arithmetic because we're adding 0.1. Now, if you didn't notice, there in Algebra 1, you learn 4 ways to represent a situation: a graph, a table of values, an equation, or a story. Now, when we're in sequences, you have your sequence, you have a situation, you have a graph, you have an equation or a recursive definition, and you have a table of values. So for this activity, Lesson 6, Activity 2, we have to match the sequences with the definitions. All right. Now, our first one, 3 plus 3 is 6, plus 3 is 9. That doesn't work. So let's try 3 times 2 is 6. 6 times 2 is 12. Our first term is 3. We're multiplying by 2. So all we need is the most important is the first term and the change. The first term is 3. So H, J, and M, 3. But which one multiplies by 2? So this one. So this one, first term goes with this one. Next one, 1836. G and K and L go by 18. But 18 times 2 is 36. So our change is times 2. Our first term is 18. Our change is times 2. And that goes with times 2L. Okay? So what we want you to see is the most important thing here is our first term and our change, which is +5 for the third one. 3 plus 5. Which one? 3 plus 5. This one goes with J. So this one goes with J because the change is +5. The next one, 18, 13, 8, 3. That's -5. And this one goes with K. So this one goes with K. Okay, so for the next one, we got 18.9, 4.5, 2.25. This one looks like it is dividing by 2. Dividing by 2 or multiplying by 1/2. Our first term is 18. And so what we have here is G. 18 times 1/2. All right, the next sequence, 18 plus 2 plus 2 does not match H, so we have to write a sequence. Remember, there's one sequence and one definition that do not have matches. So if it's plus 2 and the first term is 18, we're going to call this F. F comes before G. And we'll say F of 1 is 18. F of any term equals the previous term, the change for n greater than or equal to 2. All right, now to write a sequence for H. So H's sequence is going to go up here. 3 times 5 is 15. Times 5 is 75. Times 5 is 375. Times 5 is 1875. Okay, here's a pattern where the number of small squares increases. The number of squares increases. So the first thing we might want to do is find the sequence, the output. So how many squares? In step 1, we have 1. In step 2, we have 5. In step 3, we have 9. No, 5 plus 9 is 14. I'm sorry, that's not 9. We have 14. And if we see we are increasing, plus 4 plus 9 is the increase. What's going to be the increase on the next one? Let's think about this. We have 1 square here, then we're adding a square in step 2, then we're adding another square in step 3. Now, I bet you by step 4, we will be adding a 4 by 4 square. See, this square, for step 1 is 1 by 1, step 2 is 2 by 2, step 3 is 3 by 3. So that means step 4 must be a 4 by 4 square. So our change is plus n squared, the step number squared. So now that we have our change in our first term, we can write a recursive definition. So S of 1 equals 1. S of n equals the previous term plus n squared for n greater than or equal to 2, because we had step 1 is our 1. Okay, sketch a graph. The graph of this is going to be a curve, but this is not geometric. Not all curves are geometric, but all geometric graphs make curves. Understand that. And this pattern is neither, because we're not multiplying the same number to each term. The term was plus 4, plus 9, plus 16. So 14 plus 16 would have made 30 squares if I would have did it. Can you represent a sequence in different ways? Yes, you can. Okay, an arithmetic sequence, like we learned, means plus or minus. You add or subtract to get to the next term. Arithmetic sequence, the change is called a rate of change in this text. In other textbooks and in other classes, you will see what's called the common difference. Now, for geometric sequences, we multiply or we divide. And geometric sequence have what's called a growth factor. Now, we always think as growth as going up. There can be negative growth, so growth factor is not always increasing.